Previous videos have covered the sharp or s orbitals, where angular momentum L was 0, the principal or p orbitals, where angular momentum L was 1, the diffuse or d orbitals, angular momentum L was 2, and the fundamental or f orbitals, angular momentum L was equal to 3. For our periodic table, these four orbitals cover all of the electrons in their ground states, but what lies beyond? What would the orbitals look like if we had more elements? Or, what orbitals might excited electrons fill beyond the set of these four? Welcome to our 8th chemistry video describing how electrons fill orbitals and the shapes of those orbitals. This video looks at orbitals just beyond those for the elements in the periodic table, or the G orbitals. Electrons orbit the nucleus in a cloud or region around the central protons and neutrons and not just on the surface. But pictures actually show a surface, and for us, the electron will be inside of this surface 95% of the time. For angular momentum L equals 4, and for magnetic quantum number m equals 0, here is the G orbital. Looking similar to previous m equals 0 orbitals, remember P is the vertical dumbbell, D is the dumbbell with 1 donut, and F the same dumbbell with 2 donuts. Here we see G, a vertical dumbbell with 3 donuts. Along with m equals 0, let's overlay the shape m equals plus 1. An interesting configuration I like with the nodes coming out in between the donuts. Looking at m plus 1, we see 8 nodes lined up in the xz plane. Remember the previous orbitals, the fundamental, which had 6 nodes, and the diffuse, which had 4, and even the principal, which just had 2. As we shift to the magnetic quantum number m equals minus 1, we see the same 8-node flower shape, like m plus 1, only rotated 90 degrees in z and aligned in the yz plane. If we put m minus 1 and m plus 1 together, we can see that more easily. For L equals 4, we know that m can be minus 4 to plus 4, so let's now look at m plus 2. This is definitely a little more complicated pattern. There are a total of 12 nodes aligned in the x and y, 4 pointing up, 4 flat on xy, and then 4 pointing down. As we look at m minus 2, the common theme of rotating in z again appears. We see the same 12-node setup with 4 pointing up, 4 pointing down, and 4 flat, just rotated 45 degrees on the z-axis. If we bring back the m plus 2 orbitals, we can see them together, and, well, that's a lot of nodes. So, what will we see when we set the magnetic quantum number m equal to plus or minus 3? A different pattern, but we again have 12 nodes. This has 6 nodes in a daisy pattern, like the f plus 2 orbitals, but 6 kind of pointing up and 6 kind of pointing down. So now let's see what we have for m minus 3 orbitals. We have the same 6 up and 6 down daisy patterns we had with the m plus 3, but a rotation of 90 degrees around the z-axis. Here's what m plus 3 and m minus 3 look like when they're all together. The final orbitals are of course m plus and m minus 4. These are the limits set by having angular momentum L equals to 4. For m plus 4, we are back to having just the 8 nodes, similar to m plus 1. Instead of being in the xz plane, the nodes for m plus 4 are in the xy plane. Our 9th and final G orbital is this blue m minus 4 orbital shown here. And of course, with no surprises, this looks just like the m plus 4 orbital with the 8 nodes. It's just been rotated around the z-axis. And the final G orbitals, magnetic quantum number m plus or minus 4, here are the 2 orbitals shown together. And those are the 9 G orbitals, one for each integer from minus 4 to plus 4. Remember, for elements on the periodic table, there are no ground state electrons in these orbitals. Thanks for watching our video on Electron G Orbitals, and thanks Skydiver Tyler for asking about these, and I hope this gives a good and understandable presentation. Our next video will likely provide more detail on writing electron configurations. We hope to see you in that video, and if you like these videos, please give them a thumbs up or a comment down below and help the channel grow by telling a friend or becoming a subscriber.